Hello everyone, welcome to Talk on Civil Engineering. Let us see the basic formulas that we are going to use to calculate the different losses, the different pre-stress losses. Okay. So the first one, the loss due to elastic shortening. So this loss due to elastic shortening will be there in pre-tension members. So for this, the formula we are going to use is alpha E into FC. Okay. So here the alpha E is nothing but the modular ratio. So here you will get alpha E is equal to ES divided by EC, Young's modulus of steel divided by Young's modulus of concrete. And FC is the stress in the concrete. The stress in the concrete, simply you will get this by dividing the pre-stress force with area of concrete. Pre-stress force with area of concrete. Okay. And elastic shortening, mostly it won't be there in post tensioning, only in case if the tensioning of wires are done in stage wise. But most of the cases you won't get this elastic shortening loss in post tension. Okay, so therefore there is no formula. If it is having, so you'll be using the same formula. Okay, now let us see the next one, the loss due to creep. For loss due to creep, you can use two formulas. It is basically based on the given data. Okay, so firstly, if it is given the ultimate creep strain, so at that case you are going to use the formula, that is the ultimate creep strain into FC and the Young's modulus of steel. So this is if creep strain is given. Okay, in case if creep coefficient is given, so at that case the formula you are going to use is the creep coefficient, stress in concrete, and modular ratio. So this is if creep coefficient is given. Okay, so all are same. So if you want to calculate the stress level in the concrete, so simply you need to divide the pre-stressing force with concrete area. Okay, and alpha E is ES divided by EC. Okay, and creep coefficient basically will be giving in the question itself, and strain also, creep strain also you will be giving in the question itself. Okay, and same formula we are going to use for the post tensioning as well. Okay, so for the post tensioning, the same formulas, we are going to use the same formulas in post tensioning. And coming to shrinkage, so in shrinkage, so basically here in shrinkage we are going to use the shrinkage strain, the ultimate shrinkage strain. So the formula will be the ultimate shrinkage strain into the Young's modulus of steel, the pre-stressed steel. Okay, and here this ultimate shrinkage strain will varies for the pre-tension and post-tension. Okay, sometimes he will mention in the question. In case if it is not mentioned in the question, for that case, so if it is pre-tension, so you can directly take the ultimate shrinkage strain is equal to 300 into 10 to the power of minus 6. Okay, and for post tension, the same formula we are going to use in post tension as well, but the ultimate shrinkage strain value will changes here. So the ultimate shrinkage value will be equal to 200 into 10 to the power of minus 6 divided by log 10 t plus 2. Okay, so this is the formula you are going to use. So or generally, this this denominator you can take it as 1. That means you can directly take 200 into 10 to the power of minus 6. Okay, so here T is nothing but the age of member, the age of pre-stressed member while loading. So load చేసేటప్పటికి దాని కాంక్రీట్ ఏజ్ ఎంత ఉంది, the member age ఎంత ఉందో, that is nothing but the T. Okay, so this is how we are going to calculate the shrinkage loss due to shrinkage. Now coming to loss due to relaxation, this loss due to relaxation directly will take certain percentage of the initial stress, okay. So basically this percentage, how much percentage, the relaxation percentage usually will mention in the question itself. In case if he has not mentioned, then we are going to assume the 5% relaxation. So this is what we have assumed. Okay, so here also same thing, we are going to assume 5% relaxation. Okay, so the loss, how will calculate loss? loss is nothing but it is the 5%. That means 5 divided by 100 into the initial pre-stress. Okay, so the initial pre-stress. Here also same, 5 divided by 100 into initial pre-stress. So generally, remember, generally he will mention in the question how much realization is provided. In the absence, you can assume 5%. Okay, now coming to the anchorage slip. And so here, this anchorage slip, generally this anchorage slip will be there only in post tension member. In pre-tension, you don't have any anchorages. So you will have anchorages only in post tension, remember. So that means in pre-tension, you don't need to calculate the loss due to anchorage slip in pre-tension, because you don't have any anchorages in this in pre-tension. So you'll be having anchorage slip only in post tension. So here we are going to use the formula, that is Young's modulus of the pre-stressed wire, the tendon, into delta divided by the L, the length of the member. Okay, so here delta is nothing but how much anchorage slip that is happened. Okay, in mm, generally it will be there in mm. So the slip in mm. Okay, generally it will be 1 mm or 2 mm, like the 3 mm. Okay, so he will mention in the question, so that you will if you substitute here, then you will get the answer. So remember, so this delta will be in mm, so you have to convert this length also in mm, right? So yeah, now coming to frictional losses. Now these frictional losses will also, you don't have these frictional losses in pre-tension, but you will have in post-tension only. Okay, so for calculating the frictional loss in post-tension, the formula that you are going to use is P naught into nu alpha plus kx. Okay, so here this P naught is nothing but the initial pre-stress. So here this P naught is your initial pre-stress, and this nu is the coefficient of friction. Usually you will mention in the question itself. This nu is the friction coefficient he will mention in the question, and this alpha is the angle, the cumulative angle in radians. Okay, so the cumulative angle in radians, so that you need to calculate. So how you can calculate this means the 2 times of 4e divided by L. So here E is the dip, how much the curvature, the tendon curvature that is provided. How much tendon curvature that is provided, that is E. Suppose if this is a beam, okay, and this is the tendon profile, so this will be your E. Okay, and this will be your length L. Okay, so 2 times of 4e divided by L, so it will be the alpha value. Okay, and k is the frictional coefficient for wave effect or wobble effect. You will call it as wobble effect or wave effect. That means you can't ensure that the profile is going in the designed direction. The tendon profile, that whatever the parabolic profile that you have provided, you can't ensure that it is going in the same manner. So there will be some deviations. So that deviation we are calling it as wobble effect or wave effect. Okay, so for this value, generally he will mention in the question itself. The k value he will mention in the question, so that the same value you need to take, or else you can assume this value has, so k you can assume has 0.0015 per meter. Okay, so 0.0015 per meter you can take this value. Okay, 0.0015, and x is nothing but the length of it will be the length of the member itself, the length of the member. Okay, so P naught is the initial stress. P naught is nothing but your initial stress. Okay, so using this formula we can simply calculate we can calculate the loss due to the frictional force. Okay, so once again I will show you the entire formulas. Yeah, so here they are. So remember, in pre-tension you will have only 4, that is elastic, shortening, creep, shrinkage, and relaxation. Whereas in post-tension you will have five elements. You need the loss due to 5 factors: the creep, shrinkage, relaxation, anchorage, slip, and friction. Okay, so generally sometimes he will ask you to find out the total loss. So at that condition, you need to sum up the all losses in pre-tension. Okay, so if he asked you for the post tension, you have to sum up all these 5 losses at the end, right? So try to memorize these equations. Thank you all.